Okay, we're going to finish up our notes today for all of Module 3. We're going to finish up Section 3.8, Day 2 today. Today we're going to talk about how equations of parabolas with vertical axes of symmetry can also interact with equations of parabolas with a horizontal axis of symmetry. All right, so if we're looking at most of the equations almost all the equations we've worked at so far that are quadratic, have a parabola with a vertical axis of symmetry, and the parent function y equals x squared, and the vertex form is y equals a parentheses x minus h close parentheses squared plus k, and that h and the k controls the h controls left right, the k controls up down as far as where the vertex is located. The equations of a parabola with a horizontal axis of symmetry are of the form x equals a y minus k. Notice the k is inside the parentheses now, and the h is outside, and the x is out front, and the y is inside. These are not functions, right? Because these do not pass the vertical line test. These are a parabola that's on its side, and they do not pass the vertical line test. They are often referred to as what we call quadratic relations. And the graph x equals y squared is the parent graph for the quadratic relations that have an horizontal axis of symmetry. So if a system contains two quadratic relations, it may have 0 or all the way up to 4 solutions and everything in between. There could be 1 solution, 2 solutions, 3 solutions, or all the way up to 4 solutions. Just as with linear quadratic systems, you can solve these quadratic systems by using graphical or algebraic methods. All right, we're going to show you first by graphing, then we're going to show you how to solve them by algebraic methods. Let's look at this. Y equals x squared. That is our parent function, y equals x squared. So that is where we just take the x and square it, and that gives us our y. So we got points at 0, 0, 1, 1, and negative 1, 1. 2, 4, and negative 2, 4, and then 3, 9, and negative 3, 9. So that is our parent function for all quadratics. All right, so now we are going to graph this other parabola, which is going to be a quadratic relation, on this same graph, and we're going to see where they intersect. So in order to plot the vertex, we have to remember that our h is now not inside the parentheses, but it is outside. So that 6/5 is actually going to be the vertex, the x value of our vertex, and the negative 6, again, it's inside a parentheses, so it's opposite, so it's going to be at positive 6. So the vertex of that is going to be just to the right of 1 and the y value of 6. So I've plotted that. All right, so just like we do with vertex form with a quadratic function, we're going to solve a quadratic relation using a table. All right, so we have 6/5, 6. Now, we're not going to come up with different x values that are to the left or right. We're going to come up with different y values that are above and below. So we got 7 and 5, 8 and 4, 9 and 3, and that should be enough. Okay, so we're going to run these different y values through our function, and eventually we're hoping to find some points of intersection. So if I run 5 through the function, 5 minus 6 is negative 1. Negative 1 squared is 1. 1 times 1/5 is 1/5. And 1/5 plus 6/5 is 7/5. So that is 7/5 there. Now if I run 4 through the function, I have 4 minus 6, that's negative 2. Negative 2 squared is 4. 4 times 1/5 is 4/5, and 4/5 plus 6/5 is 10/5. Now 10/5 does simplify to 2. So we would mirror that to 2/8 as well. And then let's see, run 3 through. 3 minus 6 is -3. -3 squared is 9. 9 times 1/5 is 9 over 5, 9/5. And 9/5 plus 16, or 6/5 is 15 fifths, sorry. And 15 fifths simplifies to 3. So 3, 3, 3, 9. So we don't need to worry about the 7/5 5 or the 7/5 7 location, but we can go ahead and plot 2, 4, and that's actually already plotted, so that's one of our solutions. And we can plot 2, 8, and then we can plot 3, 3, and 3, 9, and look, there's another location. So the parabola like this is going to open pretty wide because it does have that 1/5 in front of it. It's not compressed vertically, it's compressed horizontally. So there you have it. So we actually have found our two solutions, and they are at 2, 4 and at 3, 9. All right, so here we have a quadratic system that we're going to solve algebraically. And we can use any of the methods that we have talked about. We can use elimination or we can use substitution. It does not matter which one we use. I'm going to go ahead and use substitution today. So I have y by itself. So I can take what y is equal to and just plug it in to that in the other equation. So that becomes 2x squared minus, and put this all in parentheses, -1/2 x squared plus 6, close the parentheses, equals 4. All right, and so then I am going to distribute that negative, so it becomes 2x squared plus 1/2 x squared minus 6 equals 4. And then combine like terms, 2x squared plus 1/2 x squared is 5/2 x squared minus 6 equals 4. So before I try to factor or do anything else, if you'll notice, I don't have a b term. And when I don't have a b term, the easiest way to solve this is just to use the square root property. So all I need to do is add 6 to both sides. That gives me 5/2 x squared equals 10. And then I want to get rid of the 5/2, so I'm going to multiply both sides by 2/5. So that cancels everything out on the left side. The right side, that becomes 2 times 2, so that is 4. And so now to get x by itself, I take the square root of both sides, and I get x is equal to, and I remember I took the square root, so I got to take both positive and negative, so plus or minus 2. Now, in order to figure out what the y values are for the two x values that are the solutions, which are positive and -2, I'm going to take that positive and -2 and plug it into one of my original equations. It does not matter which one. I'm going to go 2 times 2 squared minus y equals 4. 2 squared is 4, times 2 is 8. And then subtract 8 from both sides. 4 minus 8 is -4. Divide both sides by -1, and I get +4. Now, the other number to run through the equation is -2, but you'll notice the very first thing I'm going to do is square it. And so when I square it, that becomes the same as if I ran a +2 through it, because that was the first thing I did there too. So -2 squared is 4, times 2 is 8, 8 minus y equals 4. So we're back in the same place. So we don't need to run that through twice. We know that our y is going to be 4. So our solution set, our two solutions are going to be 2, 4, and -2, 4. And that's it for us. All right. Well, if you have any questions, please don't feel bad about emailing or asking or sending a Canvas message. Just shoot me something so that I can get back to you as soon as possible. Have a great day, and I'll talk to you later.